Hi everyone, and welcome to Geometry Lesson 5.5, Indirect Proof and Inequalities in One Triangle. We're going to start off by talking about inequalities in one triangle and how the side lengths and angle measures are related to each other. In a triangle, if the sides and angles are not congruent, then there are certain things that are true, and this makes complete sense if you really think about what's going on. Basically, the smallest angle is going to be across from the shortest side. The medium angle will be across from the medium side, and the biggest angle will be across from the biggest side. And this works in the opposite way too. If you can locate the biggest side, you can find the biggest angle that's across from it. Okay, so we're going to work on just identifying which angles are small, medium, and large, and which sides are small, medium, and large, and putting them in order from least to greatest or greatest to least. So let's look at some examples. In example 2, we're asked to write the angles in order from smallest to largest in this first triangle. Then we're also asked to write the sides of the second triangle in order from smallest to largest. So I would encourage you to pause this video, try and do it, and then hit play to see if you're right. The first triangle, you need to identify the smallest side, which is this one here, 27.2. So the smallest angle is angle H. So that's the first one. The medium side is 28.5. So the medium angle is this one, angle J. And then the longest side is 33.4. So the biggest angle is angle G. Remember, don't go by what it looks like, go by what the numbers tell you. Now, in the second triangle, notice they haven't told you about that last angle, angle M. But we have been studying triangles, and we know that if we add 54 plus 39 and subtract from 180, you can find angle M, which happens to be 87 degrees. So the smallest angle is angle L, which means the smallest side is segment KM. The medium angle is going to be this 54, which means the medium length is LM, and the biggest angle is angle M, so the biggest side is KL. So KM, LM, and KL. Now I have some for you to try. These are the check it out questions. You can see them in your book or you can see them on this video. So separate from your notes, please do these two check it out questions on a separate piece of paper that you can turn in at the end of the period. Make sure you pause the video, do the questions. We'll be right back with more information. The next thing we have to talk about is the triangle inequality theorem. This theorem states that the sum of any two side lengths of a triangle must be greater than the third side. So if I take AC plus BC, it has to be greater than AB. And no matter how I pair them up, the added side is going to be greater than the one that isn't added. Now, one thing that can work to help you get this done faster than doing all three inequalities is to take the two shortest sides and add them together and compare to the longest sides. That's a shortcut for using this theorem to determine whether the side lengths can be a triangle. So we're going to go ahead and practice that, and you'll see how this works. In example 3, we're asked to tell whether a triangle can have side lengths with the given lengths, and we need to explain our answer. So they've given us 3 separate examples here. So remember, the triangle inequality theorem says if I add any two of these lengths, it has to be more than the third side. So go ahead, try the example, and then hit play to see if you're right. What I've done is I've checked that the two smallest sides added together are greater than the biggest one. In the first one, the two smaller sides are 3 and 5, and that is more than 7. So yes, this can be a triangle. Now you can try the others, but 5 plus 7 is definitely more than 3, and 3 plus 7 is definitely more than 5. So really just showing that the two smallest ones added will work. Now in letter B, the two smallest ones are 4 and 6.5. That adds to 10.5, which is not more than 11. So this is not going to make a triangle because the two smaller sides are not bigger than the biggest one. In the last one, they told us what n equaled, but they gave us these expressions. So you have to figure out the side lengths first, and then you can tell if it's a triangle. So you do 3 plus 5 to get 8, 3 squared is 9, and 3 times 2 is 6. So I took 8 and 6, added them, and I saw that it was more than 9. So yes, this is a triangle. Now I have check it out questions for you that are just like that example. Please do these on that separate sheet of paper you were using earlier so that you can turn them in at the end of the period. One last application of the triangle inequality theorem is actually finding a range of possible lengths for the third side of a triangle. So they've given us two sides. Now there are a lot of ways you can do this. The book is going to say write all three of those inequalities, solve each one, and pick the smallest range of values. But the easier way to do it is to just add 6 plus 11 and subtract, so that you get a positive number, 11 minus 6. And that's going to give you the two numbers it has to be between. Let me show you what that work would look like. I added them to get 17. I subtracted them to get a positive number. Make sure it's the bigger number minus the smallest number. And that's going to get you 5. So I know that this last side has to be between 5 and 17. And it comes from the fact that the two numbers that are given have to add to more than the extra side. So notice it's less than 17 because these add to 17. And the side plus the smallest side, the side that I don't know, plus the 6, has to add to less than 11. So if I find the difference of 11 and 6, I know the smallest it could possibly be. So it has to be more than 5. So that's the reasoning going on here. But if you just remember, oh, I add them and I subtract them, and then I say that it's between those two numbers. So you can write it as an inequality, or you can literally write between 5 and 17. Okay, so I have one for you to try. Take a look at this. This is the check it out question number 4. Make sure you do this on your separate piece of paper. It says the lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possible lengths for the third side. Now there is one more example that we're going to do on this video, so press pause and then hit play when you're ready. Example 5, it says the map shows the approximate distances from San Antonio to Mason and from San Antonio to Austin. What is the range of possible distance from Mason to Austin? Now notice on the picture, they've told us that San Antonio to Mason is 111 miles, and from San Antonio to Austin, it's 78 miles. Those are two sides of the triangle that's made. So all we have to do is the same thing that we have been doing. Find a range of possible values for here. I subtracted 111 minus 78 to get 33, and I added 111 plus 78 to get 189. So it's between 33 and 189 miles. So that's it for this video. There is one more video talking about indirect proof, so don't miss that.